The probability of a single event. For equally likely events, this small p here represents our probability. And then in the brackets is of what's going to happen or what we're trying to watch. So the probability of a particular outcome, and that could be rolling a die, or it could be spinning this spinner, which has the three colors. Those are the outcomes. So the probability of a particular outcome equals the number of ways of obtaining the outcome divided by the total number of outcomes. So for instance, in this die here, you can roll the die and you have the numbers 1 through 6. So there's 6 different outcomes. Those are the total number of outcomes. Here on the spinner, you can spin it and you can get red or blue or green. So that's 3 different outcomes. So let's say we look at this spinner. What's the probability of red? Probability bracket red. Well, there's red only once here, so we have the number 1 on top. Out of what are the total amounts? We already said 3. There are 3 different colors. Those are the outcomes. So the probability of spinning red is 1 out of 3, which is fairly obvious from looking at this picture here, that red represents 1/3 of this spinner. All right, let's use this definition in some questions. So the probability of something, the number of ways of getting that something, dividing by the total number of outcomes for our test. And our test here is, a card is taken at random from a full pack of 52 playing cards. What is the probability that? And we have a bunch of different options to look at here. So the first is a red card. So what we're evaluating here is what's the probability of getting a red card. Okay, so we're looking at a pack of 52 playing cards. So our total outcome, if we're going to look at the whole pack in this case, is 52. So how many of those cards are red? Well, we know that half the deck is red and half the deck is black. So we know right away actually what the outcome is going to be. It's 1 out of 2. And also, in the same vein, there are 26 red cards. If we counted them all out of the pack of 52, and we could divide each one of these by 26, you would get 1 out of 2. So the probability of drawing a red card is 1 out of 2. B, what's the probability of getting a queen? Okay, so now we have our pack of 52 cards. Okay, we're drawing one at random. And what are the odds of us getting a queen? Well, there are 4 queens because there's 4 suits, right? We have spades, clubs, hearts, and diamonds. So the odds of getting a queen, 4 out of 52. And we can simplify that, divide each by 4, so you get 1 out of 13, which should make sense because there are 4 suits, so there are 13 cards of each suit. So there's 1 queen of each suit, so 1 out of 13 should make sense. C, what are the probabilities of getting a red ace? A red ace. How many red aces are there? There's 1. Oh, there's 2. Sorry. There's the hearts and the diamonds. So there are 2 red aces in the pack out of 52 total, and that simplifies to 1 out of 26. So the probability of drawing a red ace is 1 out of 26. Probability of the 7 of hearts, that is 1 out of 52. There's only one 7 of hearts in the entire deck, so 1 out of 52 is the probability of drawing that card. Probability of drawing an even number. Okay, we'll probably have to think about this one. The probability of an even number. Okay, well, we know there are 52 cards in the deck, so we can make that the denominator. But on top, we have 2, 4, 6, 8, 10. The Jack, Queen, King, those are the face cards. They're not even. So we either are going to draw a 2, a 4, a 6, an 8, or a 10, okay, of each suit. So that's 1, 2, 3, 4, 5 times 4. There are 20 even cards. There are 20 even cards in the entire deck. So can we simplify this? Yes, of course, we can divide each by 2. That'll give us 10 out of 26. 2 again, that'll be 5 out of 13. And we had that as well with our 2, 4, 6, 8, 10. There are 5 in a suit, and there are 13 in each suit, so 5 out of 13 should make sense there. All right, we have a bag of candy, and it contains 18 red sweets, 12 green sweets, and 10 yellow sweets. Candy is taken at random. Candy or sweet, these are the same thing. From the packet, what is the probability that the candy is red? Okay, so probability that it's red. Okay, we want to know how many reds are there divided by what are the total amount. So we need to add them up first. So we have 18 red and 12 green and 10 yellow. So if we add those up, we get 40. On top, red, how many red are there? 18. So 18 out of 40. And we need to simplify 18 out of 40. And if we divide both by 2, we'll get 9 out of 20. So the probability of pulling a red sweet out of the bag is 9 out of 20. What are the probability that it's not green? So this bar on top, G I'm using to represent green, the bar on top represents not. So this means the probability of not green. Okay, so we know that there are 40 candies in the bag. Not green, that means it could either be yellow or red. There are 10 yellow and there are 18 red. So we have 28 that are not green out of 40. And we can simplify that, divide each by 4 to get 7 out of 10. So the probability of not green in the bag, pulling one out at random, is 7 out of 10. Probability of green or yellow. Okay, so again, there are the bag of 40. There are 12 green and 10 yellow. So the probability is 22 out of 40, and we can simplify that to 11 out of 20. Probability of green or yellow, 11 divided by 20. We roll a fair die 120 times. So how many times would we expect to obtain these three different outcomes? So a 6. Okay, so the probability of rolling a 6, if we just roll it once, is there's 1 6 on a die out of 6 different numbers. So that's 1 out of 6. Now we're going to roll this 1/6 of the times we should get a 6. Now we're going to roll this die theoretically 120 times. Okay, so the expected number of 6s is going to be 1/6 times 120. We're going to do this experiment 120 times. So we should expect to get a 6 20 times out of those 120 rolls. Okay, probability of getting an even score, that's either a 2 or a 4 or a 6, that's half the time, right? 1, 3, and 5 are odd, 2, 4, and 6 are even, so 1 out of 2 rolls should give us an even number, or will give us an even number. So we're going to do that again 120 times, so we would expect that 60 times we would get an even number out of 120 rolls of the die. Probability of a score less than 5. Okay, probability of getting something less than 5. All right, so there are 6 numbers. Less than 5, that's either a 1, a 2, a 3, or a 4. Number 5 is not less than 5, and 6 is obviously not as well. So 4 out of 6 will give us less than 5, which simplifies to 2 out of 3. But we're going to do that 120 times, right? So we take 2/3, we multiply by 120, and we will get the number 40. So we would expect that we'll roll a score less than 5 40 times if we roll the die 120 times.